So now let's discuss the differentiation by quotient and the product rule. So we have this expression and we have to differentiate it with respect to x, because that is the independent variable over here. So let y be equal to this expression, which is a plus x over a minus x. And remember, a over here is being treated as a constant because we have to differentiate with respect to x. So any variable apart from x will just be treated as a constant. So we do this and we can solve this by using the quotient rule. And the quotient rule states that if you have let's say you have a function of x called u of x, and that is being divided by a function of x called v of x, and you have to differentiate it. So basically d of this over dx, that will be equal to basically v of x into u prime of x, and all of this subtracted from u of x into v prime of x. So basically the derivative of v with respect to x over v of x square. So we'll apply this formula over here, and as you can see, that is what we've done. This is the expression in the denominator, which is basically v in the example in this over here, and that is being multiplied with the derivative of the numerator, and subtracted from this is basically the derivative of the denominator multiplied with the numerator, and into the denominator of this we have the square of the denominator over here in the original question. So oops, just a second, let's just take this all out. So we have this over here, and the derivative of a plus x is basically equal to 0 plus 1, because a is being treated as a constant and the derivative of a constant is 0, and the derivative of x to the power 1 is just 1, and same goes for a minus x, because a again is 0 and x is 1. And by the way, just for clarification, when two things are being added up and you have to derivate that, you'll basically separate that. You'll take the derivative of a first, and then you'll add that into the derivative of x, and same goes for here, the derivative of a and minus the derivative of x. So that is what we've done here, and so you're left with this, and after doing the multiplication and calculation, you get this x and this x will be cancelled out because they'll be subtracted from each other, and then you're just left with 2a over a minus x whole square. Let's go to question 5. That states that we have to derivate this expression with respect to x, because that is the independent variable over here, and 5 and 3 are constants. So we'll use the product rule over here. So the product rule states that when you have to differentiate two functions, so let's just take u of x being multiplied with v of x, that will just be equal to the derivative of u multiplied with v plus the derivative of v multiplied with u. So that's just written over here as well. So once you do that, again, this is this function, and that will be multiplied with the derivative of 3 minus x, and that will be added with 3 minus x multiplied with the derivative of x minus 5. Simple. So how do we find the derivative of 3 minus x? Well, we'll derivate 3 with respect to x first, and then we'll derivate minus and then we'll basically subtract that from the derivative of x with respect to x, and over here this will basically be done by we'll derivate x with respect to x, and then subtract from that the derivative of 5 with respect to x, And that just gives you, for the case of 3 minus x, that just gives you 0 minus 1, because the derivative of 3 with respect to x is 0, because again it's a constant, so that just leaves you with 0. And the derivative of x with respect to x is 1. And same goes for here. The derivative of x with respect to x is 1, and the derivative of 5 with respect to x is 0. And the rest remains as it is. Yep. And so upon calculation, this is the final answer that you get. You can also take 2 common over here if you want.